Welcome to another Darkest Before Dawn developer vlog. I'll be showing you guys the roof system that I added, and as well as some modifications that I made to the wall logic. So let's take a look here. Before, we gotta put some floor down to allow the walls to go up. I think I'm going to change this. I'll probably remove the restriction for it to have to be floors. Perhaps if you want to be like inside a shelter, if you want like the shelter stat, you'll have to have like a wall underneath you and a roof above your head. But I think in general, we don't need to have the roofs. So what you can see here is a few things that we've done. So now you only get just regular pieces about the size of a block, and then when you get a corner piece, you get this tie-in, because they usually have to like tie the logs together, so you get some extension. It's usually what you see in log houses. So that's what we've done. And another thing I've added is this dithering effect. So when you can see, otherwise when you were behind here you wouldn't be able to see what kind of items you have stacked there. This way you can kind of see what's going on behind there, and you know it's obvious that there's still a wall there. It just kind of clears away. I might play around a little bit with how many walls, like the radius that this area dithers by a little bit, but in general that's pretty much it. So let's finish making these walls here, and I'll show you. So what we do now is these walls raycast like front left and front right to see if they have any corner pieces, and if they do, they're just basically instructed to make an offset piece, and if there's one in each corner, they make a long piece, because that means it's only one piece long. Okay, so I haven't added the ability to make the roof remain on the clicks, but as you can see, there it is. So once you walk under a roof, the roof disappears completely, but the walls only half disappear, and that's a stylistic decision. I think having any part of the roof visible would be kind of distracting, while having an idea of where your walls are pretty important. The other thing that we did was we made the walls snap into a grid. So there's it's a little bit of logic that goes into it, but basically once you place something next to it, kind of if you played Space Engineers and you're familiar with the grid system that they have there, that's kind of what I was following. You can see as soon as you walk under one of the roofs, the entire roof disappears and the entire roof comes back all at the same time. So yeah, one more thing I'll probably have to add here. You can see, you can't see the player. So the way that this works, the roof system works, there's a ray that shoots up from the player. If it collides with a roof, then the roof disappears. Now that's fine when he's underneath the roof, but you can see I go right over here and he's not underneath the roof. I can't see the player because the roof's in the way. So the shoot up to see if a roof is there, I think, is important for like the stat, if you want to be like hiding from the rain, or if we need to figure out if you're inside shelter or not. The logs work on a slightly different system. What they do is there's, from the center of the screen, a ray gets shot out directly forward. Well, it's actually offset a little bit. I have a little bit that it kind of offsets it down, just so we're not making walls disappear that are above us, only below us. So the ray kind of shoots right at his feet, and anything that collides there basically disappears. And this isn't, the ray that gets shot out isn't just like a point ray. These are sphere casts. So imagine like a cylinder being shot out, and that's what's hitting, and we're basically reading all the colliders that it hits and applying logic to them. So I think what I'm going to add is the same type of system that I use for the walls, I'm going to add to the roof. So that way when you're outside here, you know, these colliders will still be hit, and then I'll still have the ray being sent up from the player to actually check if the player's in shelter or not. So let's just finish building out this roof here. So the next few things I gotta add some upper walls, some walls that kind of fit into the edges of the roofs here. Ability to add doors and windows. Okay, here we are in the roof script. I just wanted to show the logic behind how the grid system works. So when a new roof is created, the first thing it does is it runs this function. And what it's trying to do is to find out if it has any neighbors. So what we're doing is we're going to look for neighbors. We're going to cast a sphere cast, which, like I said, it's like a cylinder or like a fireball that you're sending out, and it basically anything that it touches, it's going to put that into an array, which is like imagine like a list of things that you have. So what we're going to do is with this list or this array of things that we have, we're going to iterate through them. We're going to go through each one. And if that particular collider that got hit by the cylinder sphere cast is a roof, then we're going to find out if this is a unique grid. So each roof, you know, if it got started on one side and another piece got started on another side, until they connect, they're going to be different grids. Basically what this will do is it will identify if there's only one grid, it will add it to that grid. If there's multiple grids, it will merge the grids together, and if there's no other grids, it'll create a new grid. So what we're going to do is we're going to discover all the unique grids. We're going to go through all the grids, and we're going to write down what number it is, and then for each grid that we go through, we're going to go through that list that we just created of numbers that we found, and if that number is already on there, we're not going to add that number. If that number is unique, then we're going to add that number to the list and keep iterating until the entire list is done. Next thing, we're going to iterate through the list again, looking for grids to merge together. So basically, if we have more than 0 unique grids, meaning there are neighbors, we don't have to create a new grid. We have 2 options. If there's only 1 grid, our option's pretty simple. We just add that block to the existing grid. Otherwise, it means we have multiple grids, and we just have to select. We have to merge the grids together. The way I decided to do this is basically put everything in the lowest numbered grid. So what we're going to do is we're going to find the lowest number. So what we're going to do is we're going to go through them. We're going to record which the lowest one is, and then we basically concatenate. We add all the grids to that grid, and when we do that, we also have to assign the grid number and the instance of each roof property. That's really important because when you say you want to remove a roof piece, when you go to stand under it, it doesn't try and turn off something that doesn't exist, because that might cause errors. And then we have to assign a new grid number because those grids that got merged are no longer what they used to be. They're all now the lowest grid number. And then if no grids were found, pretty simple, we just basically start a new grid. And then down here we just have our dithering effects. All we're doing is we're lerping, which means it's a linear interpretation between one point and another. And we're just creating an interpretation, which is the current time divided by the total time that we want it to take. So you'll have a number between 0 and 1, and then we interpolate that through here. So we say this is where we want it to start. So that's the setting. This would be make invisible. So we're going to start from fully visible to the level of invisibility that we want to achieve. And then this is the interpolation will just be like a percentage, a number between 0 and 1, depending on the variables that we selected. And then it's just going to apply that to the materials, and that's it. The make visible is the same thing. It's just the reverse of that. The only other thing that I didn't mention, so rather than starting from the maximum and the minimum, what we do is we take the current. That way, if it's halfway through an interpolation already, it won't jump to the other end of the spectrum. It'll start off from where it is at the moment. And that's about it. So I'm going to start working on the windows and doors, and I'll wrap it up there.